Okay, this is going to be a round of 64 knockout solution to the portals case, which is a really cool case. So essentially you have these maps, which is a 16 by 16 grid. The O's represent portals, so you'll start in a cell, walk to the closest portal, and that will portal you to another area. And the unique thing about this case is that all of the maps are on different tabs, so you have like 64 maps instead of one map to work off, which brings some complications. So if you want to see me jump straight into the solve, skip ahead. But before that, I just want to talk a little bit about lambda and what my approach is when you have to find things that are closest to you on a map. So a while ago, I made a lambda to like pull things within an area around me on a map, and it's a fairly complicated lambda. The best example use for it is this spreadsheet is a nightmare. So you have this giant map here, which is huge, and you're given a location and asked to find the closest alien or ghost to you. So I made a lambda that kind of does that. So if I say closest on map, I can pick a cell, so this cell, and then I just basically highlight my whole map, and I give it an extension. So an extension of 0 will just give me my cell. An extension of 1 would give me a 9 by 9 grid, so everything 1 away. So for this example, let's just try an extension of 5. So this is going to give me everything 5 cells away. It's basically going to tell me what is in that cell, first of all, what cell that is in, and then the distance. So when I originally made this, I had diagonal distance only built into it. But a couple of the cases, including this portal one, you want to find the closest things where you're not allowed to move diagonally. Now I didn't know that watching the case video, but I did know that there was a specific order you would like to follow. So in this nightmare case, there's only ever one thing that's closest, which is, you know, this alien. So this was very easy. I could just then do a data table and pick the first cell address in my table. So for example, if I just move this to the example here, you'll see DK200 is the top item and it's an alien. Now, I kind of was in a bad habit of using this lambda for anything where you have to find the closest thing to you. So when we got to this #1 fan session, for example, the final question was Lana banana, and it asked you to find the closest banana to you, and you're going to go and keep collecting them, you know, given a specified order until you can't anymore. And the preferred order in this example kind of aligned with 2col. So she would always want to pick something that was further up in a row, and if there was a match, so these are in the same row, she'd pick one of the first columns. And if you 2col this map, you will run along here, then along here, then along here. And I could make that work quite well because if I go back to my nightmare case, this is kind of exactly what's behind this lambda, is a 2col of the map. So the preferred order always spits out how I want it. Now in the video for this portal case, the preferred order is to actually go down a column first, and then if there's multiples, you choose the lower row. So that changes things a bit, and what you can actually do is 2-column map and scan by column, so the 2col will come out in this order, down columns like that. So I did actually make a lambda before the case that kind of uses my closest on map lambda, so if I go back to my nightmare case, then ordered this based on the row and column, which is underneath the lambda, to calculate this distance. And then I could turn that into a lambda that was like closest portal to just give me a cell address. When I actually got into the case and saw that you couldn't move diagonally, I had to kind of amend some of the lines in the lambda to calculate the correct distance based on that fact. So I've now updated my lambda to have a load of optional arguments. So the first one here is whether I restrict diagonals. So if I say 1, it's going to restrict diagonals, and you'll see that these distances increase because we can no longer travel along diagonals. And the second optional argument I've added is to filter for an item. So if I only wanted ghosts, for example, I could put an alien, let's say aliens. I'll put an alien in, say F9, and then this is only going to filter to aliens. That's really useful for this portal case, which I also added in my pre-work because I had 15 minutes before the case. And the final thing I've given is this optional argument. Now, I really wish in lambdas you could do something like this weekday, where you have this whole list of optional arguments, but unfortunately I don't think you can. If you can, I'd love to know. So what I've done is I've said my order is, so row, column, ascending, ascending, column, row, ascending, ascending, so my 8 possible orders. So you can either prefer to go to the lower row or lower column, and then again, once you've got there, the lower row or column, or the uppers. So that gives you basically 8 possible combinations. So I have 8 possible combinations here. So 1 is the normal 2-col order. 2 is the 2-col order, but you go down. 3 is whatever it says here. So 3 is column row. 3 is row column with the row ascending and the column descending. So I could order this, by 2, and it will spit out the right order for this portal case. So that was kind of I did what I needed to in pre-work just to get this case done, and then later on today I've added all those other 8 options for orders. So wow, that was a long explanation of this lambda, but this really kind of carried me in the case. Even though I got the last question wrong, I made a stupid mistake, so I'll come to that when we get there. I was thinking about whether I do Dim's Lana Banana approach, where I just 2-col the map that I need to find the closest portal, and then, you know, the top one in that list would be the preferred one. But yeah, I went with my lambda, and hopefully now I've built it out a bit more, that will see me through some future cases quite well. So let's get to it. Which area has the most portals? So basically for this one, I just did, so I started out by going equals this, because I kind of want to build an indirect that references that. So I want to go area, so equals area and sequence of 64. And that's going to give me all of the start of my areas. So for here, I can say equals this, which is my area 1 part, and this. What that's going to do is it's going to, if I indirect it all, it's just going to spit out that exact map. So let's just move that across here. And basically I want to count if this is a portal. So I'm going to say count if this is O, and we get 3. So then I can just XLOOKUP the maximum of this in here, return the area name, and that gives me area 19. This is also quite nice for question 1, so let's do that now. How many portals are there in the area that you are in? Let's just do insert a column here, equals sequence of 64 again, and I'm going to say equals XLOOKUP this in here, return here, and that's going to give me all of, you know, how many portals are in each area. I'll continue on the bonuses. I think I could actually do this one now, but I will. I'll do it later. So which area appeared most across all levels, excluding examples? So this is where I use my case questions lambda. I could probably modify this. I have all the NAs because if I ever want to 2-col it, 2-col gets rid of NAs, or if I do most of, which is another lambda I have, then that's also built to just, you know, get rid of them. So a lot of the times I can answer bonuses by just literally writing this and, you know, putting an @ symbol before it to find the most common thing, or, you know, or whatever it might be. The problem in this case is that the question numbers are also included. Sometimes bonuses ask you for only question 7 or only question 6 or whatever, so it's actually going to count these as well. So in this instance, I will just get rid of everything, you know, points, question number, level, and just take that, and then I can basically say equals most of this, and I can see that 11 is the most common area, so we can say area 11. Okay, across all the games, how many areas have you been to that contain the number 6? Oh, sorry, across all the games in level 7. So for this one, I just came down to level 7, and I literally did equals search 6 in here. That's going to tell me if it's there or not, so I said minus minus is number that. And then I just summed them all up, and I can see that that's 13. So 13. Take the sum of the row number for all the portals in each area. Which area has the highest total figure? So again, I want to do kind of something like this. So let's just go back to what we have here and remove this. So this is area 1. So I'm just going to say equals area 1, and I want to do sequence 16 because that's my row numbers, and then I want to do count if that whole row has a portal, and I want to times it by the row number. So there's 1 portal in row 4. If there were 2 portals in row 4 and I want to sum up the row numbers, that would be 8. So I'm going to times that by the row number, and then it's essentially the sum of those. So I'm going to say equals sum of this, and then I'm going to do a data table here on this, doesn't work for some reason. Ah, because I haven't referenced over here, that's my bad. There we go. And then again, we're going to do XLOOKUP max of this in this, return this. I missed a bracket. So area 40. And the last one, which area doesn't have any portals in A to K. So I can do the same thing here, just not times it by that U3, and I want to amend it to be A to K. So that will be A, B, C, D, E, F, G, H, I, J, so one more. And there we go. We want to know where that's 0, so I'm going to change that max to min, basically. I assume the minimum will be 0, nothing has negative portals, area 63. So that's the bonuses. Now let's get into question 2. So I'm just going to basically delete this out and go example 2. Then I can just data table all of the questions here, so I'll set it up for the whole case. G to I. And this is asking for how many portals are in each area, so I'm just going to do my whole indirect thing again to pull out the map. So indirect, I want to say area, and this number, and that. So that's going to give me my map for area 1, and then I want to say count if it has a portal, and then I can just drag that along, and then my sum is those, fine, doesn't matter, and I just data table that whole thing. That should be the answer. Okay, and then the portals can appear in odd or even numbered rows across all the areas. How many portals appear in an odd or even row? So let's do example 3, and we want to go out to L. So example 3, and we want to go out to L. So the way I did this, it's going to be a nightmare trying to pull a map, pull things on just a row. So what I opted to do is just highlight all of the tabs. So if you shift click a further tab, then what you do in one tab will be done in every tab exactly the same. So then I said count if this is a portal, dragged it all the way down, and if I go to another tab, you'll see that that is present in every tab. It's evaluating a 0 at the minute because I've not refreshed. If I go into an individual tab and refresh, now all of my tabs are refreshed, so I pressed F9 there to refresh. So now I have in column Q kind of everything I need. So I can right click here, go back to my data table, and instead of pulling out A1, I pulled out Q. I'm just going to do the indirect to spit it out. So area is this. Just pull that here. So these are basically my rows, and now I want to just pull out odd or even rows. So I literally just did if this equals even, then choose rows of that, and I just literally did 2, 4, 6, 8, 10, 12, 14, 16. Otherwise, I'm just going to put all the odd numbers in there. There's probably a quick way to do this, but this is just what came to me off the top of my head. So I did 1, 3, 5, 7, 9, 11, 13, 15. And then it's going to only, reduce the number of rows, and then I just sum those up. I'll just move my data table across a bit. And then I just pulled that across here so that I would get the numbers for each of those, and then I could just sum those up. So sum of these, and let's go put our question numbers into the data table. At this point I was really itching for the movement kind of questions come up, because I spent like 15 minutes building the Lambda before and hadn't seen it yet. So which area has a portal in this address? So for this one, example 4, I want to pull out G6 for every area. So again, let's do our equals area, area and sequence of 64. And then I want to do equals indirect of this, and I'm going to say change the area 1 bit to that, and then say and that. Actually, I don't want to say and that, I want to say and G6. I just want to pull a single cell. So I need to actually lock that. And then what am I trying to do? Find out where a portal is. So I can just say xlookup O in here, return here. And it's going to tell me the area. So that's that one. Then what do we have? This is where the lambdas start to come into play. So based on your starting position area, what is the minimum number of steps to get to the closest portal? So example 5, C3, and we have an area here. So I basically did, I'm going to pull my indirect thing here, I'll get rid of this junk. So area, and that, and I'll just pull this again because I can't be asked to write it. So I think that gives me everything. Yeah, that gives me my whole map again. And what I'm trying to do is I'm trying to do my closest on map thing. So I want to find like what's closest to C8 in that area. So I said closest on map, this cell, there's my map, and my extension I said 15 because that's the most I could move in any direction. And then in this lambda I'm going to restrict diagonals. I built the lambda out so it already did that ahead of time. So I'll just show you what that looks like for now without anything else. That's just going to give me everything with the distance. Now if I wasn't doing it with this lambda, what I would just do is I would pull this map out kind of like I did with this indirect. I would then 2-col it, so I'll just show you over here. I would do 2-col this, and I would 2-col it by scanning by column. And what I would then do is I would get the addresses, so I would say equals address. So the row number is going to be a sequence of 16. The column number is going to be a sequence of 16. And I will use relative references. And what that will do is it will give you, I need to do a comma before that so it spills out like that. So that's all my cell addresses. And then I would 2-col that in the same vein by scanning by column. And then I would be able to, pull out a distance, and that would be that. So the distance calculation would be, the row minus the column, row minus the row, column minus the column, add them together, and that's how to do it. Anyway, let's continue with this close map lambda. So my item is a portal. So that now looks like that. And my ordering, preferred order, is going to be 2. So basically, I just want to pull out the top cell every time is going to be my preferred place. Or I'm asking for the distance. So actually, the distance is just going to be this cell every time. And then question 6 is just asking for the cell. So all I need to do for this one is pull out this every time. This is where the lambda really helped me because I didn't have much time left by the time I got to this spot. And then the final one is basically going through a number of areas and then finding the sum of the distance. So it's what I just did, but 2D basically. So let's say example 7. We have the cell there, and what we want to do is we want to pull out the, what do we want to pull out? We want to pull out where we're going, and yeah, okay. So I want to 2-col, I'm not explaining this very well. I'm going to 2-col this, and that's going to be my area. So my first area is going to be here, and I'm going to put C3 in this cell here. So I'm going to say equals C3. Then what I want to do is I want to pull out where I'm going. So I'm going to go to G4. So actually what I want to do is I want to take 2 rows. So if I say take, row is, I want to take first row and I want to take the last 2 columns. So then I can just pull that down and, you know, I go from C3 in area 1. It takes 5 steps to get to G4 where a portal is, and then from G4 to H4 and so on. The last one doesn't matter because the question is asking how long it takes to get to the last map. So I'm not going to then go to this map and then walk to a portal. So the answer will be the sum of those. And yeah, I actually got this question wrong. So I didn't, in the real thing, I didn't finish the last 2 bonuses because I ran out of time. I thought I had done this, but my mistake was that this cell I manually typed as C3. So I was going from C3 on every single question, which probably lost me the points. It was something silly like that I did. Now, if I was not to do this, because this is probably not very educational, what I would do is I would, first of all, let's keep just my indirect part of this lambda. I would 2-call that, scanning by column. I would then do the same with the addresses like I did earlier, 2-call address, and then sequence of 16, sequence of 16, and I would again scan by column, and then I would need some kind of distance. So for my distance I would do row of indirect of this minus row of indirect of this. That's going to give me the, whoops, I missed some brackets there. That's going to give me the row difference. I would wrap that in at absolute, and I would do exactly the same for column. If this was diagonal, I would take the maximum of these 2 instead of the sum of these 2. And that's going to give me the distance from everything. And because this is in the preferred order, I just need to lock B1 here. Because of the way I 2-called this, it's already in the preferred order. I would filter this to only portals, so let's just do that over here. So there you see you've got these 3 options, and it's always going to be in the order that's preferred. This might not always be in the right order. So what you'd do is you would XLOOKUP the smallest thing in here, so 0, and then exact match your next smaller item. This, you'd get G4 as your next spot, and then you could essentially repeat this process. So you'd put that kind of underneath all of these areas, do it for each area, find your new cell, and continue on until you could add up all of these distances. That's essentially what my lambda's doing in the background. It's just obviously, now I've built it out, is a lot more versatile and can do a lot more things. So that is that. Boosted by my lambda on this one, but I need to do something to stay in the competition because it's getting hard now with the opponents. I probably didn't explain all of these lambdas that well, so I'll probably do a lambda video like before, maybe before the next round or after it. I'll probably go out in the next round, to be fair, because yeah, I have a good collection of lambdas now, which are really starting to boost me in these cases. Cool. See you next time.